Hey everyone, this is 2.4 formulas. This section isn't really word problems, but they might involve words and pictures, but really they're going to involve formulas that compute specific things like area or volume or circumference. So here's a couple formulas here that we might be using. These first two you should probably know. You should probably have memorized. This last one's a little bit different, not as common, so typically we don't think of you as memorizing them, but this is actually the area of a triangle, the circumference of a circle, and the volume of a cylinder, and we'll look at some of those right now. So if you want to calculate the area of the triangle, first you have to know what the formula is, and so again, this is the area of a triangle formula, 1/2 times the base times the height. So in this picture, this is the base, 5 inches, and this is the height, which is 6 inches. So when you plug it in, you get area equals 1/2 times the base, which is 5, times the height, which is 6. Right, so I'm just plugging them into the formula, and don't forget you can do this in any order you want. So I would actually just multiply the 5 and 6 first to get 30. Oops. And multiplying something by a half is the same thing as taking half of it, so half of 30 would just be 15. And now when we're calculating area, it's a two-dimensional measurement. We're trying to figure out how much space is taken up here. So instead of regular inches, we're going to have square inches. Right? It's like saying if you make a 1 by 1 inch, a 1 by 1, yeah, 1 inch by 1 inch square, how many of those could you fit inside the triangle? Well, this is saying that you could fit 15 of them inside. Okay, so that's your area formula, and make sure anytime you compute area, you always have square units. Here they want a circumference and area of a circle. So here's our circle over here. And what they're giving us, by the way, is called the radius. The radius is the distance from the center to the edge. The distance all the way across is called the diameter. The distance around the circle is called the circumference. And the amount of area that it's taking up is called the area. So we'll start with circumference, which is the distance around. And the formula for circumference is c equals 2 times pi times r. Now let's talk real quick about pi. Most people think of it as 3.14, which is great. That's actually it's actually a decimal that goes on forever and doesn't repeat, so there's way more than 3.14, but most people just use 3.14 as a rounding. The reason behind pi, where it comes from, is if you take any circle, if you take the distance around it, its circumference, and you divide it by the distance across, you'll always get the same number, the same ratio, and that ratio is pi. It's like 3.14159, etc. It goes on forever. Right, so that's where the number comes from. Any circle, if you take the distance around divided by the distance across, you get pi. That's why it shows up in formulas of pretty much anything round or circular. Alright, so let's go ahead and dive into the circumference here. It's going to be c equals 2 times pi times the radius, which is 3. So if you multiply the numbers, you just get 6 pi. And this is what we call the exact answer because you haven't rounded or approximated, you just left pi in there as a symbol. Obviously, if you want to do a real calculation to use it for something in the real world, you want to plug in an approximation for pi. And again, we mostly use 3.14 as the approximation. So if you replace pi with 3.14, 6 times 3.14 will give you 18.84. Now this was circumference, and circumference is in regular old, let's move it over, regular units. So this started in feet, these will be actually in feet. Because it's just like perimeter in this case. It's not feet squared, just the distance around is in feet. For our area, it's going to be very similar. We have pi times r squared, which is 3 squared. That gives us 9 pi. That's our exact answer. And if you want to plug that into a calculator, do 9 times 3.14, which I'm going to do real quick. You should get 28.26. And these are going to be square feet because it's area. Right, so the circumference, this first answer here, is measuring the distance around the circle. The area is measuring how much space the circle takes up. Distance around is in regular feet. The space it takes up is in square feet. So there's an example of circumference and area. So another fact you're going to have to know about triangles is that the sum of the angles in a triangle is 180 degrees. This means if you take 3x degrees and 4x degrees and 2x degrees and you add them all up, you can set them equal to 180. That's what we're going to do in this case, is they want us to solve for x, so we need some kind of relationship between our x's. So it turns out, in this case, 3x plus 2x plus 4x will equal 180. And then we can solve this equation pretty quickly because these are all like terms on the left. So 3 plus 2 plus 4, that's 5 plus 4 is 9x equals 180. And then we can solve for x just by dividing by 9. And we get x equals 20. Actually, we don't need the degrees, huh? X equals 20, but if we wanted to figure out the degrees, then let's see. This would be like 60 degrees here, right? 40 degrees and 80 degrees. 60, 40, and 80 make 180, so this is our answer. Here's a formula that doesn't have to do with geometry. This formula converts degrees Fahrenheit to degrees Celsius. So basically, if you take a temperature in Fahrenheit, plug it in for F, crunch these numbers, it'll spit out the temperature in Celsius. So I did an example here. If F is 50 degrees Fahrenheit, I plugged in 50 for F. 50 minus 32 is 18. 5 nines times 18 is 10. So it turns out that 50 degrees Fahrenheit is the same thing as 10 degrees Celsius. Now that's nice if you want to convert Fahrenheit to Celsius, but what if you want to convert Celsius to Fahrenheit? You could plug in the C here and then do the algebra to solve for F, but you can actually take the general equation and instead of having it solve for C, like C equals, you can do algebra to make it F equals. So this equation is set up to take Fahrenheit to Celsius, but you can solve it to take Celsius to Fahrenheit, and I'll show you how to do that. So here we go. Basically, we want to take this equation and we want to solve it for F. So if you want to solve it for F, there's two things you're going to have to do. You have to get rid of the 5/9 and get rid of the 32. We're going to start by getting rid of this 5/9. So we're going to multiply both sides by the reciprocal, which is 9/5. Right? Remember, this is our trick with fractions because the 9's will cancel and the 5's will cancel. So what we'll get is we'll get 9 over 5c equals f minus 32 because the 9/5 went away. And so now if you want to solve for f, you add 32 to both sides. And we get, make some room real quick, we get 9/5 c plus 32. Notice these can't combine because we don't know what c is and they're not like terms. Equals, and those canceled out, so we get equals f. So this is the same formula, but now that it's solved for Fahrenheit, for f, this formula now converts degrees Celsius to Fahrenheit. So if you have a temperature in Celsius, you plug it in, multiply by 9/5, add 32 to it, and it spits out the temperature in Fahrenheit. The other types of problems we can do this section involve solving equations for different variables, kind of like we did in the last example where we solved it for f instead of c. So this first example is something you're going to do a lot in Chapter 3. Take an equation with an x and y in it and solve it for y. This is actually putting it into what we call slope-intercept form, or y equals mx plus b, which again we'll talk about a lot in Chapter 3. So if you want to get this equation, if you want to get y by itself in this equation, you're going to have to start by getting rid of this minus 3x. So my first step would be, let's add 3x to both sides. Remember, we're doing the opposite. Those cancel out, so we get a 4y equals. Now on the right hand side over here, we can't combine 12 and 3x because they're not like terms. These are x's, these are numbers. So what I'm going to do is I'm going to write the 3x part first, 3x, and I'll write a plus 12. Now it's true, you could call it 12 plus 3x, but again, because this is something we're going to do in Chapter 3, we're going to want the x to be first. I want you to get in this habit now, so put your x's first. Okay, so now all we have to do to get y by itself is divide by 4, and I'm going to divide everything separately by 4, again, because this is how we're going to do it in Chapter 3. You could do a big fraction on the right, but it doesn't matter. 4's cancel, and we get y equals, this one we're just going to call 3/4 x, because we can't divide 3 and 4, and this one we're going to call 3, because 12 over 4 is 3. So we just took this equation, the one we started with, and we solved it for y, we got this equation. They're still the same equation. Later when we're graphing, they'll still have the same line. It's just that now it's solved, it's set up for x, or sorry, it's set up, solved for y. And later when we see our mx and b stuff, this will be our m, our slope, and this will be b, our y-intercept. Here's another similar example. You have an equation. This one actually has 4 different variables. All they want us to do, though, is get b by itself, right? So this is the one we want to get by itself. So we're going to have to get rid of the 2 and get rid of the a and the c. Start with the 2. If you have a 2 there and you want to get rid of it, remember fractions are nice because, well, equations are nice with fractions because you can always get rid of them by multiplying both sides by either the denominator in this case or the lowest common denominator if you have multiple. So what this does is the 2's cross cancel. They go away. On the left side we have 2s equals, now that our denominator's gone, we just have a plus b plus c. And now if you want to get b by itself, you basically have to subtract the a and subtract the c. I'm going to kind of do 2 steps at once. So minus a minus c over here. So we end up with 2s minus a minus c equals b. Now it's not a very satisfying looking answer at first, but it's actually exactly what we need. All we needed was to get b by itself. We know we're not going to be able to combine s, a, and c because they're not like terms and we don't know what they are. So in this case we just have an expression b equals 2s minus a minus c. And that's our answer. So that's it for 2.4. Let me know if you have any questions and keep up the good work.